So let's check our solution on this one. We have to do some stuff with justifying, so I kind of have some things graphed here so you can just check. All right, our first equation, y equals negative 2x minus 1. So that tells us that our slope is negative 2, right? We could write that over 1. Our intercept is negative 1. So we're going to start by plotting a point at negative 1 and then down 2 over 1. Again, right, just as a reminder, we're sort of making as many points as we need. We don't know how many points that will necessarily be each time, so just sort of filling in so you see enough. Right, then we'll look at our second equation. This has a slope of 1/2 and an intercept of negative 6. So we're going to start down here at negative 6, and then we'll go up 1 over 2, and right there is our solution. If we name this point, this is the point positive 2, right? 1, 2, 3, 4, 5, negative 5. So that makes our solution 2, negative 5. Okay, so it uses the word approximate here because it's not telling you what the solution is. It doesn't want to give anything away, right? We can always tell what the solution is by where the 2 points intersect. Okay, you can justify by plugging in your x and y values. And since we did get an exact answer on this one, it is possible for us to justify the solution, right? And to justify, we'll be plugging each of those x and y values in. Okay, so this says that our x value is 2, our y value is negative 5. Okay, so we'll say negative 5 equals negative 2. Okay, our x value is 2, so times 2 minus 1. So negative 5 equals negative 4 minus 1. So there's our first one being true. Now we need to check and make sure we get the same thing over here. So again, we plug in our x and y values. So y is negative 5 equals 1/2 times 2 minus 6. So this is 1 minus 6. So again, we get negative 5 equals negative 5. And since both of those are true statements when we plugged in the value, we're able to justify and show that our answer is correct.